Right. In this video I'm going to go through Vision software download and installation for the precision tester. And then I'm going to install the tester, go through the procedure under Windows 7, and then we'll begin our first Vision startup and do a few Vision basics to get you started. So the first thing I do is I go to www.ferrodevices.com. And this is the home page for the Radiant Technologies website. Click on the menu option for Vision software. This is a brief discussion page of the Vision software. I'll go under the Vision download and update, and it opens this form. Fill in the form completely. And once you've filled it in once, it should automatically fill in for you depending on your browser. And you want to do this regularly to check to see if there's an update to your version, Vision version. The same installer that you use to install Vision will be used to update it. Please let us know that you're installing Vision for this particular piece of hardware. Click Submit, and I'm taken to the Vision installer download page. Go down to the middle and click the download button. This should take a few minutes. It's about a half a gig. Once the download's complete, use whichever technique you'd like to run the software. I usually go to the download page and run it from there. Double click on the installer, allow it to run. Now, the first time you install, you'll find that you need to install these Visual Studio 2005 redistributable files. And that takes a little while. When the installer begins, you'll see that there's a license page. The license basically gives you information about the latest updates. This software is freely licensed to all users, and you can load it as many times and as many places as you would like. So I agree to the license, and installation begins. Once installation is completed, the installer automatically opens the Radiant Technologies YouTube site. This is a nice site for more advanced operations, including demonstrations of some of the accessories that we can include with a precision tester. This site will grow and become more general purpose, including the video I'm making now. Let me show you that, first of all, Vision installed several folders throughout your system. One of these is the datasets folder. Another is the RT USB folder, and then the final one will be the Radiant Technologies folder. If you're installing under Windows 8, 8.1, or 10, before you can install the tester, you have to go through a series of procedures to tell the host computer not to enforce driver signature. You need to disable driver signature enforcement, and that includes a reboot into a boot up that disables that. In order to do that, several documents are loaded under datasets documents. And one of those documents at the bottom here is instructions on how to reboot your tester with driver signature enforcement, depending on the Windows type. For Windows 7, I don't need to do this. What I'm going to need to do is turn on the tester. Now, Windows should try to install the tester and fail. Under Device Manager, Devices and Printers, the tester shows up as an unknown device. If I turn it off, this window will refresh and it'll go away. If I turn it back on, here it is. In order to install under any of the versions of Windows, I need to right-click, go to Properties, go to Hardware, Driver, and Update Driver. From here, I'm going to go Browse My Computer. Then I'm going to go to the Browse button, go to C RTUSB. OK. We'll read CRTUSB. Next, it begins installing the driver. The driver isn't fully licensed to Windows, so it needs to be given permission to install. And there's the tester. Radiant Precision Premiere 2. Now I'm ready to start Vision. Now, several things have been written to the desktop. I have a datasets folder, user printable help, and Vision task. These are three key folders in the Vision software installation. I won't be dealing with these right away. I'm going to start Vision. The first thing you see on startup is the tester selection dialog. This dialog does a number of things, but primarily it just shows you that the tester is connected. Here's a name that's written into the tester EEPROM. You can select the tester, and you can also rename it from this dialog. If I click OK, it's going to tell me to disconnect anything from the drive BNC port on the tester. It may be connected. And then it's going to go through, when I click yes, through a period of calibration. Once the stop button disappears, Vision's in its idle state and it's ready to operate. Now, the first thing I'd like to point out is the help pages. One of the things we may ask you is the Vision version. If you're trying to help us troubleshoot about Vision, we'll tell you. Also under help is where you should really start to work with Vision. The Help Topics project will open a project, and it gives you some general information, but really the place to start is under the tutorials. I highly recommend you start with the beginning tutorials and work your way all the way through. This should take 5 or 6 hours. At the end of that, you'll be very expert with the program, and you will also save a lot of work time. Now, Vision is a framework program that provides services to a series of semi-independent agents that we call tasks. Tasks are configurable, executable programs in and of themselves. On startup, Vision locates all the tasks it can find and loads them into a place called the task library. And you can see that there are several categories of tasks. A subset of the task library is loaded into a menu called the QuickLook menu here. So I'm going to start with the hysteresis task. The hysteresis task is probably our most general purpose and most common measurement in the ferroelectric polarization versus field area. So go to hysteresis, and what opens here is a configuration dialog. Now this is a QuickLook configuration dialog. This is the QuickLook menu here. This is the QuickLook configuration dialog. A number of things about this dialog. First of all, you'll notice it's very complex. So you'll also notice that this button here is blinking. This is the only task it does this, and it only does this on the QuickLook configuration dialog. Once I click the button, another help project opens. Now the button becomes steady and is forever steady after this, unless you completely uninstall Vision. Okay. But what opened here was a hysteresis task-specific set of help pages. And all help pages, all tasks have a help page, and all help pages have roughly the same format. You begin with a discussion, which will talk about task construction, operation in general, theory of task operation, limitations, any number of general discussion items. This is followed immediately by a series of pages on the configuration of the task. Right now we're in QuickLook configuration. And these also have a very specific format. At the top is some tabular information about the task, the same for every task, the same set of basic information. This is followed by how you access the task, and then a series of images about the configuration of the task. And these images differ depending on the configuration. Then there's a discussion, a detailed discussion of the controls that are found in the images, and then a control by control table giving the control name, the type of control, its default value, and a discussion. And within discussion, you also find that there are relationships between controls. So if, for example, the state of this control affects the state of another control, that's discussed here. All of the controls are discussed. Now, with the hysteresis task, there are some subdialogues that may appear. So beneath that control is a section on the subdialogues, the various subdialogues that will appear under hysteresis, and what they mean and how they're configured. In the case of configuration, what we're going to do in place of QuickLook, what we're going to do is configure the task and run it. It's going to present a plot. So there's a second tab here, the plot setup tab, and we'll see that in a moment. Same format, and it discusses configuring how the data are going to appear once they're finished being measured. Here is the task configuration dialog. Now, regardless of the rest of these controls, what's important is, first of all, the task voltage. I'm going to make a 9-volt measurement. The task period, or hysteresis period, 10 milliseconds is good. The hysteresis name. Now this is a QuickLook measurement, and we'll see that maybe in this case the documentation isn't quite so important. Nevertheless, this is where you would name the task, and I highly recommend that you give it a unique and meaningful name. The only other control I'm going to do is I'm going to check this Enable Ref Cap. And what that does is it switches a 1 nanofarad linear commercial capacitor into the signal path. This is internal to the system. So this capacitor, this 1 nanofarad linear capacitor, is going to be measured by the hysteresis task as though it was a sample under test. Now, if I connected a sample and I had this checked, I would be measuring both the connected sample and the internal reference cap in parallel. So this would be adding signal to the measurement. I wouldn't normally want to do that, so if I connected my own sample, I would uncheck this. There's also a 2.5 mega ohm linear resistor. And there's actually, in some tester models, an internal reference ferroelectric capacitor. I'm going to do the internal reference cap because I know its characteristics and I know what I expect. Sample area and thickness are also important. Area actually figures into the measurement by scaling the charge data read off the sample in order to provide polarization. Microcoulombs per centimeter squared. Centimeter squared is the sample area. Thickness is more of simply documentation, but if you want to plot your data as a function of field rather than voltage, then the thickness is a key element in that calculation. In the second page, I have the plot configuration, so I'm going to give it a title. All tasks are fully set to documenting. They all have a task name. They all have a 511-character comments field to allow you to permanently document the task function and perhaps a sample setup, what the sample's made of, how this experiment is being used. So here's my configuration. Now if I click OK, it's going to begin to make the measurement. You'll see that it has the stop measurement button. If I clicked this, I would get an error, and the data would have no meaning. At the end of the measurement, this dialog appears showing me the resulting data from the measurement. And this is exactly what I expect. I expected the sample to respond between minus 90 microcoulombs per centimeter squared at minus 9 volts to plus 90 microcoulombs per centimeter squared at plus 9 volts. Some of the configuration parameters are here. Some of the what we call single point values derived from the measurement are plotted here. We'll discuss much more of this as time goes on. But if I close this, I'm done. The data are gone. They're not saved anywhere. I've lost my measurement. QuickLook is designed for a quick, let's see what we've got sort of execution that tells me my system's working, that my sample's working, but it's not intended to save data, and there are a number of consequences. Nevertheless, all is not lost even under QuickLook. If I can go Control R, I recall the exact configuration that I just executed. I'm going to re-execute. Here's my measurement. Now, we're going to move into a realm in Vision that it is intended to operate and that will save data for us. And we're going to save this hysteresis measurement to a Vision data set. And to do that, I'm going to select Save to New Data Set. And then I'm going to close the dialog. Next thing that happens is I see a new data set dialog appear. Create a Vision data set. By default, this goes under the datasets folder. I can put it anywhere I want by opening the browser and browsing to a location. It also has a name that I can edit, but it is a file name that ends in star.dst, but is based on the hysteresis dataset name. Again, I can give this name anything I want. But as long as I'm editing this field will be updated. It also requires that I put in my initials. Comments are optional. Click OK. The data set is created and the task is copied in. And a field appears that allows me to give the record a permanent name. Alright, so I give it a unique and meaningful name, and when I click OK, the data set is updated. So now there are a number of components here. This is the data set. Here you'll see that there is a tab open in what we call the Dataset Explorer. Dataset Explorer lists all registered data sets. This is a new data set. It's located directly under the datasets folder, and here it is here. It also is open. I can open any number of data sets. This one is open in its own tab right here. Here is a dataset log window. Here is what we call a current test definition. Now, a test definition is an experiment. An experiment is formed by a linear series of tasks. In this case, the test definition has a single task, the hysteresis task we just executed. Below the archive is what we call an executed test definition. The executed test definition takes the name that I just assigned, and underneath it has two folders. There's an experiment design and an experiment data. Now over time these will differ, but here's where we're interested. Here's the experiment data, and here's the hysteresis task I just made. If I double click, first thing I see is the configuration. So the task is self-documenting. Everything about this task and its configuration is available to me. As I close this, I get a plot setup dialog again. So now I can adjust the way the plot is set up and reconfigure it and have it appear differently. I'm not going to do that for the moment. If I close this, there's my data. I can go back and recall it again. Among the options I have to plot is not only the titles and the comments that are involved, but also I can apply a plot filter. And this is strictly before the plot. The data are not changed in any way in the archive, only when they're plotted. And there are a number of filters, and I'm not going to go through those, but one of the ones that we use regularly here in our tester evaluations and in our debugging is simply to plot the data as a function of time. And in this case, what you get is a polarization and the drive voltage as a function of the time, the 10 milliseconds of the sample. Okay. If I close this, now I'm going to run the test again from QuickLook. I went Control-R, opened up the configuration dialog, exact same measurement, configured exactly the same way. Now you'll see that the plotting option is persistent. Doesn't matter. Now I'm going to go here, I'm going to go Save to Open Dataset. Again, I'm allowed to rename my current test definition. And my second measurement from QuickLook is now saved to the same open dataset. And here are the data. Back to centering. We'll discuss centering. Or you can always determine what centering is by going to Data Plot Filter Manipulations. And it talks about all the different manipulations that we do to the data and different data presentations. And down here is polarization as a function of time, which is what we're looking at. Okay. Put it back to centering and show it. Rather than going back to QuickLook, I want to record this data, make this measurement one more time in QuickLook in the data set itself. All I have to do is press F1, and the measurement begins in the data set. One thing you notice, when I make this measurement using F1, no data appear. There's no representation of the data anywhere. In order to view the data, I have to go back to the archive and recall the data from the archive. Now the data are apparent to me. Let's remedy the fact that no data are displayed when the task is executed. I'm going to start by going back to the task library. Under hardware, okay, so hardware tasks are tasks that send signals to the precision hardware. Under that, there's measurement tasks. These are tasks that also receive data back from the hardware. And then there's the hysteresis category. And we're going to go to the hysteresis task, and I can either drag it into the editor, or I can right-click and select to editor. Configuration dialog opens. Now this configuration is a little bit different. It's a little more involved. I'm not going to go into any details now. And instead of selecting the enable ref cap, I'm going to enable the ref ferroelectric resistor. And there's two options. I can actually do these in parallel, but I'm going to just do cap A. And I don't know what condition it's in. It may not look very good for this demonstration. This is for permanent record. What I've got is essentially the same thing as I have over in the data set, except that instead of measuring the internal linear capacitor, I'm measuring an internal ferroelectric capacitor. I right-click, and I select Test Definition of Current Data Set. Then I give it another name. Click OK, and now I've got a new current test definition. If I check it, double-click it, I could open the configuration to see how it's configured. I can see that the ref cap, linear ref cap is not selected, but the ferroelectric is. So if I run this, again, no data appear. I have to go to my archive, open the data, and there's the ferroelectric. In order to make data appear, what I'm going to do is add a filter. I'm going to a very simple filter task. Now, filters are tasks that do four things. They collect data from one or more input measurement or filter tasks. They manipulate the data. They plot the data, and they store the data. I'm going to add a collect plot filter. Very simple filter. It does all of those except to manipulate the data. I'm going to take a single hysteresis task. So in order to configure this, and this is going to be the same for most filters, I'm going to select the hysteresis input data type. And what's listed here is all of the hysteresis tasks that appear before the filter in the data set, in the test definition. And I'm going to select it, and I'm going to click Add Task. And you'll see now that there's an X associated with the hysteresis task that indicates that it's been associated with the filter as input. The collect plot filter is going to plot these data because I said it is. I've enabled the plotting on execution. So what I'm going to do is configure the plot simply by giving it some titles. Now when I click OK, I'll notice that there are two tasks in my test definition in the editor. Now I can reconfigure or review the configuration simply by double-clicking. If I make no changes, I click OK. If I'd made changes and clicked Cancel, then the changes would not have taken effect. And I can review the configuration of either test. Now I'm going to right-click and go to Current Data Set. And I'm going to go with Filter. F1, and I make the measurement. Now I see that the data are plotted. This is a conventional data plot for filters. This is the plot window, and then here's some information about the input task. If I go farther, I can get a little more information. I can do a number of things by right-clicking on the data plot. I can add, for instance, grids. I can resize the data. I can maximize. And any number of other options. Under the archive, I now have two tasks in my test definition. The hysteresis task is here, and the filter task is here. Again, the data are archived. Again, if you'll notice, I can export the task to Excel. I'm not going to create a file name for it, so when I close this, it's going to ask me if I want to save. There's a third task in the experiment data, and this is actually a task that you can configure, but this one's added automatically. This is a general information task. Now, the general information task is a program control task. It's program control documentation general information. And what happens is that the program itself adds this task, prepends it to the test definition. It gives it as an identical name each time, auto ETD summary. And what it is it's a summary of the construction of the test definition, task by task. So this is when it was executed, some vision information. Then their task 1 is hysteresis, task 2 is the collect plot filter. The thing that's unique about the general information task is it is composed of a discussion or comment that has no limit on the number of characters. So you can put a great deal of detail about your experiment into your test definition record by including a general information task, normally at the beginning, but this is added automatically by Vision. I can also add a general information task immediately to the test definition by right-clicking, configuring, and adding it in as its own test definition. The advantage here is that the way Vision is designed is that once data are captured, they're indelible. They cannot be removed. So if you have an error or something, or there's a change that you made that wasn't documented, anything like that, and for any reason you want to add an immediate piece of information into the test definition without going through the process of creating a new test definition in the archive, you can do that by right-clicking and appending a general task. And there's a number of other options that we'll discuss at some other video. And I think that's a start for you with Vision. And with that, I'm going to end this video.